right, so on Friday we worked on adding, subtracting, dividing, and multiplying functions. So that's what we're going to work on right now. Just do another couple examples of that. So go ahead and write down those two problems there, or the problem right there, 44. And again, we're going to add that, subtract it, multiply it, and divide it. So what makes this problem a little different from what we did on Friday is that it's a rational expression. Okay, so it has a fraction on the top. So we did rational expressions earlier on in the year, so we're going to have to recall that information as we go through here. So when we go and add fractions, so remember the first way is f plus g of x. That just means we're adding the f function, which is 3x plus 1 over x squared minus 25, plus the g function, 2x minus 4 over x squared minus 25. So remember, in order to add fractions, what do we always have to have? Common denominator. We have that already, so that makes life a little bit easier, because once we have common denominators, we just leave our common denominator on the bottom, and we add straight across. So I'd have 3x plus 1 plus 2x minus 4. I'm just going to combine like terms along the top, and I would have 5x minus 3. I do want to look to see if I can always factor this. I can't factor, there's no GCF in 5x minus 3, there's nothing I can factor. So that's my numerator, and our denominator is x squared minus 25 still. So f plus g of x is equal to 5x minus 3 over x squared minus 25. Now, for us to also find the domain, that's the other part of this question. For us to find the domain, we are going to have to factor the denominator of the common denominator, or any of those denominators. So what does x squared minus 25 factor to? Okay, so these are, again, x plus 5, x minus 5, which if I said x cannot equal negative 5 or positive 5, because either of those would make it equal 0. So as I go through my domain, I'm saying x can't equal 5 or negative 5, because negative 5 plus 5 is 0, making the whole thing 0, or 5 minus 5 is also 0. But remember, when we write that using interval notation, I'd have an open dot at negative 5, an open dot at 5, and shading everywhere else. So therefore, my interval notation for the domain would be negative infinity to negative 5 with a parenthesis, because again, it's an open dot, union negative 5 to 5, parentheses for both of those, and then from 5 to infinity. Again, everything's parentheses because it doesn't equal 5, doesn't equal negative 5. If we are subtracting f minus g of x, same thing, now we just have a minus sign instead of a plus sign in between. So again, in order to subtract, we need a common denominator. We have that, so therefore, we can just go ahead and make it one fraction, put that common denominator at the bottom. Now the big difference is because we are subtracting, remember we have to subtract that whole quantity, so I have to put that 2x minus 4 in parentheses or brackets, because I have to make sure I'm subtracting that whole quantity. So that would give us 3x plus 1. I'm distributing the negative sign through. Minus 2x plus 4. And then as we add like terms, 3x minus 2x is 1x. 1 plus 4 is 5. Now this is where it gets a little interesting because we are going to have to factor that denominator now, because remember our denominator is difference of squares, so that factors to x plus 5, x minus 5, and then what happens in this particular problem that we can do is still right, we can cancel out the x plus 5s. So we are left with a 1 on top and an x minus 5 on the bottom. Our domain is still the same as what it was before. That's not changing. So we can just go ahead and rewrite that. It still couldn't be negative 5 or 5. So our domain goes from negative infinity to negative 5. Negative 5 to positive 5. And then 5 to infinity. So that's the subtraction. Our multiplication so I'm doing f times g of x. So that would be 3x plus 1 times x squared minus 25 times 2x minus 4 times x squared minus 25. Okay, so we can go ahead and make that one fraction. So I would have 3x plus 1, because remember when we multiply fractions, you multiply straight across. 2x minus 4. And then I'm multiplying x squared minus 25 times x squared minus 25. So that would be x squared minus 25 quantity squared. Now we'd want to see if we can simplify this any further. So I'm going to FOIL the top. That'd be 6x squared minus 12x plus 2x minus 4. So when I combine the like terms on the top, we get 6x squared minus 10x minus 4. And then on the bottom, it's a binomial squared, so we can do our shortcut of either writing it twice and foiling it, or square the first, double the product, square the last. So again, if you forgot how to do that shortcut, you'd have to write it as x minus 25 times x squared minus 25 times x squared minus 25. But shortcut, square the first, x squared would be x to the fourth. Double the product. Our product is negative 25x squared, so that would be negative 50x squared. And you square the last. 25 squared is 625. And again, our domain is still going to be the same because it was still the same parts. Nothing's changed. So negative infinity to negative 5, negative 5 to 5, and then 5 to infinity. And then last but not least is the division. So f divided by g of x. So that would be 3x plus 1 over x squared minus 25 over 2x minus 4 over x squared minus 25. So remember, when we're dividing these, what's our little statement for dividing fractions? A little trick. Keep, change, flip, right? So we gotta do the keep, change, flip here. So we're keeping that first fraction the same. I'm gonna go ahead and factor this a while. X plus 5, x minus 5. You don't have to because it's gonna be the same thing, but. So keeping that first fraction the same, changing that division multiplication, flipping this fraction, and I'm gonna factor that fraction as well. So x plus 5, x minus 5, and I'm gonna factor a 2 out of the top there. I did a keep, change, flip, and I factored at the same time. Any factor on the top can cancel with any factor on the bottom. So x plus 5, x minus 5's cancel. I can't factor anything else, so we are left with 3x plus 1 over 2 times x minus 2. And again, we'd have the same domain restrictions, -5 and 5, but now since this x minus 2 is also on the denominator, we have an additional restriction. So now it's 5, -5, and also positive 2, because 2 minus 2 is 0. So that changes up our number line a little bit. We'd have -5, 2, 5, open dots on all of those, and shading in between everything. So this is f divided by g of x, and then our domain is a little bit trickier. It's going to go from -infinity to -5, from -5 to 2, 2 to 5, and then 5 to infinity. So, having the rational expressions changes it up a little bit, because you got to remember all those little tricks for that also. All right, you're going to try 46. So just as you go through this, your common denominator would be x minus 4, x plus 8. Remember, you multiply any missing factor on the top and bottom. Okay, so the first fraction, when you're adding, has the x minus 4, but doesn't have the x plus 8. So you have to multiply top and bottom by x plus 8. Second fraction has the x plus 8, it's missing the x minus 4, so you got to multiply top and bottom by x minus 4. So we have our plus and the minus, and our domain is not changing for any of them. When we're multiplying, that's probably the easiest. You're just going to get 9x times 7 is 63x. And on the bottom, you don't have to FOIL it. You just leave it as x minus 4, x plus 8. And again, the domain and range is not changing at all. So the domain is the same. Sorry, the domain is the same for all of them. We're not worried about the range right now. And then when you're dividing, you're doing that keep, change, flip. So that would flip your 7 and your x plus 8. So you would just have 9x times x plus 8. And then the 7's on the bottom, so it'd be 7 times x minus 4. again, your domain is not changing. So the domain was the same for all of them. I'll give you a little bit more time to work. If you did not get any of them, just let me know. All right, so that kind of closes out our adding, subtracting, multiplication, division. Again, just a new wrinkle on this was the rational expressions, which made it a little bit more challenging. So that's why we went over that today. Going into what we're going to be doing over the next couple of days is we're going to be doing composition of functions, which is where you're kind of putting a function within a function. So this is kind of a brief intro to that. So we have to remember our function notation when we do composition of functions. So if our function is f of x equals 2x squared minus 3x, remember whatever's inside those parentheses is going in for the x, right? So if I'm doing f of 3, I would say, all right, in for all the x's would be a 3. So it would be 2 times 3 squared minus 3 times 3. And then I have to follow PEMDAS. So I have to do the exponents before I multiply. So this would be 2 times 9 minus, I can multiply that a while, 9. And I have to multiply before I subtract. 18 minus 9. So I'd say f of 3 equals 9. Go ahead and try f of 5 on your own. Take a moment and do f of 5. So replacing 5 in for the x's, I would get that. Again, I have to do my exponents first, so I'd have 2 times 25. I can go ahead and multiply 3 and 5 together, so that'd be minus 15. This would be 50 minus 15, so we get f of 5 equals 35. Now we can also plug in variables in as our input, so now if I put 5x in instead of just a number, I can do that. So I'm replacing all the x's with 5x, so it'd be 2 times 5x quantity squared minus 3 times 5x, like that. Now our answer isn't going to be a regular number like it was for the first two. Our answer will have an x in it. So I would have to first square 5x. So that means I'm squaring the 5 and squaring the x, because that is one big term. It's not a 5 plus x, it's a 5 times an x. So that would give me 2 times 25x squared. And then I would also do negative 3 times 5x, which is negative 15x. And then I can go ahead and multiply the 2 and the 25x squared together. So my answer here for f of 5x would be 50x squared minus 15x. I can't combine any of those like terms, so we are just finished. Now, as we go to that last one here, f of 5x plus 1, that's where it gets a little trickier. Because I'd be doing 2, and then the quantity of 5x plus 1, quantity squared, minus 3 times the quantity of 5x plus 1. And the reason that's a little bit trickier is because how do I have to do 5x plus 1 quantity squared? You're either going to have to write it twice, which you can if you'd like, or you can do your square the first, double the product, square the last. I'm going to do that one. So if I square 25x, I get 25x squared. I multiply 5x and 1 together, get 5x, and I double that to get 10x. And I square the last, which is 1. I'm also going to distribute that negative 3. I get negative 15x minus 3 from I'm going to have to distribute the 2 here. So I get 50x squared plus 20x plus 2. And then we can just combine like terms. 50x squared plus 5x minus 1. Alright, and so we're going to build off that a lot tomorrow, putting like functions within it, not just so having answers that have x's in it.